Welcome to another session of Maths Fanatics. In this question, we're going to be looking at the laws of differentiation and the first principles. Okay, so without wasting any time, let's start. So on 8.1, they want me to determine the derivative of f of x from first principles. Ne? Remember, when I see first principles, I'm thinking of this formula. Limit sh approaches 0, f of x plus h minus f of x all over h. And ladies and gentlemen, this formula is always given in the formula sheet, right? But I always advise you to know all the formulas off by heart. Because if you know the formula, chances are high that you'll know how to use it. Does it make sense? So learn them off by heart. That for first principle, I'm going to be using this formula and know how to write it without even looking at the formula sheet. But yeah, that is going to take you time to practice. It comes with practice. But for now, if you don't know it, you can always look at it in the formula sheet. Okay, perfect. So I want to find this part now. This part I have already is there, right? The f of x. So let's work it out here. So I have f of x equals to 3x squared. That part I'm sorted. I need to get this part now. I need to get f of x plus h. I'll show you how to do it now. Okay, f of x plus h basically means this. You see here there's x, right? There's x there. Now, where there was x, they replaced by that, right? They replaced x by that, which means even on this side where there's x, I must replace by that. Okay, so I'm going to have 3. Where there's x, I open a bracket. I'm going to put this x plus h squared, right? And then we need to simplify this. So I have 3x plus h, then another bracket, x plus h. Because of the square, it means 2 identical brackets. So now I'm going to FOIL here, which is going to FOIL to x squared. This times that gives you plus xh. This times that gives you plus xh. This times that gives you h squared, right? Perfect. And then from there, we're going to have this now. We're going to have multiply the 3 in. We have, okay, before we do that, let's do this. Let's add like terms inside. So I have x squared. Here I see that I have a 1. I also have a 1 there. So, and these two terms are like terms. So I'm going to have 2xh plus h squared, right? Which basically become 3x squared plus 6xh plus h squared. I'm now multiplying the 3 in. Okay, perfect. And then from there, I can now substitute. So this is equals to limit sh approaches infinity. This part is this part, right? F of x plus h is that. So where there's f of x plus h, I'm going to put 3x squared plus 6xh plus h squared. My x looks like a multiplier. Let me make them like this so that they are more clear. Sharp. And then minus f of x, which is 3x squared all over h. Now we're going to have, so if you check, this will be negative 3x squared is going to cancel with this one, right? Perfect. So now we're going to have limit sh approaches infinity, 6xh plus h squared all over h, right? Which is equals to limit sh approaches infinity. Here I'm having a common factor. So after the step of cancelling, you're always going to have a common factor. In this case, my common factor is h. And your common factor will always be h. Always. It's always h in first principles. So h, and then here I'm left with 6x. Here I'm left with h. So 6x plus h all over h, right? Perfect. So this h will cancel with that one. And then I have equals to limit sh approaches 0 of 6x plus h. Ne? And then the step after you cancel the h, you always substitute the 0, but you don't show the substitution. So for example, any part that has an h in simple terms is going to disappear. 6x doesn't have an h, it stays, right? Then this part is h, so it's going to be 0, so it disappears. So your answer must be that, right? Perfect. And then the first principle question, you are always going to just verify it, ne? Using the rule. Remember, first principle is just the long way of the rule of differentiation. So if I have f of x equals to 3x squared, the derivative of that can be written as, remember, we take this, we multiply with the exponent, so 3 times 2, it's 6, then we have x, then we take the exponent, we minus 1. So 2 minus 1 is 1, so I have 6x. Do you see it? 6 to the power 1, which is 6x. And then you know that you are done. You did it properly when it's like this. Ne? You know that you did it properly. So now let's move to 8.2. So on 8.2, we're just going to be doing the same thing that we've been doing on 8.1, but now we're not going to use the first principle. Remember, the first principle is too long, right? You only do first principle if they tell you to do first principle. If they don't, you just use the rule of differentiation. Okay, so I have f of x equals to x. Okay, let me just write there. There's 1, but they expect you to know there's 1 there. Ne? They never show it. I'm sure by now you should be knowing this. Minus 3 plus 9 over x squared. Okay. So here, before we differentiate with the rule, guys, ne, we need every term to be over 1. You cannot use the rule if one of your terms is not over 1. So this part here is over 1, we sorted. So I have 1x squared minus 3 over 1, which is fine. Here I have over x squared. So this x squared must move up, ne? Must go up. So we have 1, then 9 is going to be x negative 2. Remember, when you move up and down, the sign of the exponent changes, right? So it was a positive. Because I moved it up, it becomes a negative, ne? Exponent. Perfect. Now I can use the rule, ne, of differentiation. So the derivative of f of x is, remember, you say 2 times 1 is 2. Then you write your x, and then you say 2 minus 1, it's 1. So we don't usually write it, right? Perfect. So I'm not going to show it. The derivative of a constant is 0. This one you should know, ne? The derivative of a constant is 0. So a constant is a term without x. When we are deriving, it disappears. It becomes 0, ne? Sharp. And then here, I'm going to have negative 2 times 9, which is negative 18. And then I have x, and then negative 2 minus 1, it's negative 3. And then that's finito for that question. Ne? Awesome. Sometimes they'll tell you to leave your answers in positive exponents, but in grade 12, it's not usually going to happen, but let's just do it for the fun of it. So we can write this as this, and then I have 18 to the power x over 3 at the bottom. So the sign changed from negative to positive because it went as down as the denominator now. Okay, perfect. Let's do 8.2.2. So on 8.2.2, I have g of x, which is equals to, x plus 3, right? Then I have square root of x minus 1. Okay, so I'm going to explain something about turning a root into an exponent. Let's say I have a inside here, and then let's say the root here is m, the exponent here is n. this can be written as a, right? And then to the power n over m. Ne? The exponent inside becomes the numerator, the root becomes the denominator. Okay, this is the most important rule you should know for calculus. Ne? So for example, remember a square root, we have a hidden 2 here, right? So we have a hidden 2 here, and then there's 1. We have a hidden 2 here, then there's 1, right? So remember I said you write x, the inside exponent becomes a numerator, the root becomes the denominator, then plus 3. Then you have the same thing here, minus 1, I mean over 2, then minus 1. Then now we're going to start foiling. X half times x half, it's x to the 1, right? Because remember, multiplying same basis, we just add the exponent. Half plus half will give you 1 there, right? 1 and then 1 here. But they don't show this, guys. I expect you to know that they are here. I'm just showing you now for practice purpose, okay? Sharp. And then x to the half minus negative 1 is just negative x to the half. And then this one times that one is just negative this to the power z, right? Then this one times that one is z, right? Sharp. And then now we can start differentiating. So I'm going to show, when you differentiate, you have to show that you're starting. You see, even here I showed. If you don't show, it's wrong. Because if you don't write this part, the marker or the examiner will assume that from here you are just simplifying, but it will still be f of x basically. So when you are deriving, you have to introduce the derivative. So the derivative of x is 1. Sharp. Because here I'm going to have 1 times 1, which is 1. And then here I'm going to have 1 minus 1, which is 0. So I'm going to have x to the power 0, which becomes 1. So the derivative of x is 1. The derivative of a constant is 0. Then here I'm going to have negative, let's see, 1 over 2. The x is the denominator, so it stays there. And then here I'm going to minus 1. So half minus 1 is minus half, right? And then we're going to have minus 3 over 2, because this half times negative 3 is negative 3 over 2. Then the x is at the top to the negative half. Remember, we said the derivative of a constant is 0, so that part disappears, right? Then this should be your final answer, right? Now, for the fun of it, if you leave it here, you get all the 4 marks, ne? All 4 marks. But for the fun of it, I want to simplify it further, ne? So the derivative is 1. I'm going to write all exponents as positive now. 1 over 2, which was at the bottom, x goes at the bottom now, then it becomes to the power positive half, minus 3 over 2, right? X to the power positive half, right? Actually, ladies and gentlemen, if we check here, I left something out, no? This part, sorry about that. This part and that part are like terms. You see them? They are like terms. So I can add these numbers, no? You can add these numbers. So negative 1 over 2. Let's get the calculator. So we have negative 1 over 2 minus 3 over 2. This should give me negative 2, right? So basically, my answer is this here. It's 1 minus 2x to the negative half. Ne? Awesome. So now, here I basically have this. Let's see. Okay, I'll just cancel this part quickly. So I'm going to have this. I'm going to have 2 over x to the power half, because this part is negative, it goes at the bottom to become there, né? Which is 1 minus 2. I can take this to a root, square root of x. Then that is just me playing around with it. But if you leave it here, you should be fine. Né? And then that's finito for this question. Again, if you found this helpful, please share with family and friends, and advise them to subscribe to the YouTube channel for more fire content like this. Thank you.